Hello everyone, welcome to GATE Academy Global. So GATE 2020 and the discipline electrical engineering, we have another question from the subject electromagnetic, and the question is: a conducting square loop of side length 1 meter is placed at a distance of 1 meter from a long straight wire carrying current I is equal to 2 ampere. The mutual inductance between the conducting loop and the long wire is. So this is the long wire in which the current is flowing of 2 ampere, and at a distance of 1 meter a conducting square loop is placed which is having the side 1 meter along the x-axis. We have to find the mutual inductance between these two. So how do you find the inductance? So actually the definition of the inductance is nothing but it is derived from the flux linkage, because we know that the current the flux linkage is proportional to the current. Okay, so let's write the flux linkage is proportional to current. Why it is so? Because when the current flows through the conductor, magnetic field will be generated, and this magnetic field will pass through some surface, so it will generate a magnetic flux, and when the magnetic flux passes through the number of turns, it produces the magnetic flux linkage, and ultimately when we increase the current, the magnetic field will increase and it increases the magnetic flux, which increases the magnetic flux linkage. So the source of the increasing of the flux linkage is nothing but the current. So if we increase the current, the flux linkage will also increase, so it is denoted by lambda and it is proportional to the current. If I remove this proportionality, then it is equal to the L into I, which is the inductance, which is called the self inductance. But because in this case we want to calculate the inductance between the two conducting loop, which is the single wire and the square loop, we will replace this self inductance with mutual inductance. So this is Mi. So this M will be lambda divided by I, and the flux linkage is actually the flux passing through number of turns. So flux is denoted by phi and it is passing through the number of turns N divided by I, and because this square loop is having only one turn, so that's why the formula of the mutual inductance will become phi divided by I. So ultimately if we want to calculate the mutual inductance, we have to calculate the flux. And how do we calculate the flux? So the flux is measure of magnetic field lines passing through any surface. Magnetic field line passing through any surface. So how here the magnetic field is generated? Because it is having the current. If the current will flow in this, then also the magnetic field will generate, but here it is given that the current is flowing in this infinite long wire. So if this infinite long wire is having some current, then it will produce a magnetic field around it. So this magnetic field will be like this, it will be passing through this loop. So the magnetic field will be generated around the conducting wire in the circular way. So when this magnetic field line passes through this surface, it will generate a magnetic flux. So let us say at any distance x from the conducting wire, we are having a small strip. This small strip is in the direction of x, so that's why let's take it as dx. So we are having the small strip dx. We want to calculate the flux passing through this small strip. Okay, so flux passing through strip dx is, that is d phi, because we are calculating the flux in the very small portion, but we know that the magnetic field lines are passing through whole square loop. So that means it will generate more flux, but we are now calculating the flux passing through very small strip dx. So that flux will be called as small flux. So that small flux is d phi, which is nothing but the magnetic field multiplied with area, magnetic field multiplied with area of the strip, because we are calculating the flux through the strip. Now, what is the area of a strip? So the area of a strip is, the side of the square loop is A and this strip is having very small length, which is dx. So the area will be A into dx. So this is very small flux d phi. Now the total flux is phi equal to integration d phi. Now this will become integration b into a into dx. So now what is the magnetic field? So at that particular distance x, what is the magnetic field? So in this particular distance x, the magnetic field, because magnetic field due to the infinite long wire, so magnetic field due to infinite long conducting wire is given by B is equal to mu naught into I divided by 2 pi into rho. Rho is called the perpendicular distance from the wire to the point where we want to calculate the magnetic field. We want to calculate the magnetic field at a distance x, because we are calculating the flux at a distance x. So this is 2 pi x. Now the total flux phi equal to integration B is equal to mu naught into I upon 2 pi x into A into dx. This is the area. So this mu naught into I into A upon 2 pi is constant, and integration 1 upon x dx. So we are integrating with respect to x. So let's substitute the limit of x. So where the square loop is starting from the x equal to b to the b and plus a up to this point. We want to calculate the flux through this particular square loop, which is at distance b from the infinite long wire to the maximum up to the b plus a. This width is a and this is b, so b plus a. So the limit of x is b to a plus b. Now the integration would be mu naught I into a divided by 2 pi, and this is natural log of x, and the limit from b to b plus a or a plus b, which can be written as mu naught into I into a divided by 2 pi natural log of b plus a divided by b, which can also be written as mu naught into I into a upon 2 pi natural log of 1 plus a by b. Now this is the total flux, but the mutual inductance M is defined as phi upon I. So if I divide it by I, then this I will be in the denominator, so we get mu naught into a upon 2 pi, which is mu naught into a upon 2 pi and natural log of 1 plus a by b. This is the mutual inductance. Now let's substitute all the values. So mu naught is having the values 4 pi into 10 to the power minus 7. A is the side of the square loop, which is given as 1 meter, divided by 2 pi and natural log of 1 plus the distance is b is also given as 1. 1 plus 1 divided by 1 is 1. 1 plus 1 is 2. So this is natural log of 2, and when we solve this, we have to calculate the value in the nanohenry and also up to the 2 decimal places. So when we solve it, you will get 138.63 nanohenry. So the value of the mutual inductance between the straight wire and the square loop is 138.63.